So today in this particular class we will be learning what is class, and we will be starting with this particular chapter. And as I have said, as we have discussed right now, class is nothing but a blueprint. Now the question is, what is the memory size of it? And you have stated it correctly but not 100% correct. Yes. So we can say that when a class is defined, it comes with many objects and many methods and everything. There are much more things that is present when a class is defined, and there the memory size is decided. That is, as you have said, it is still dynamic, but it will be having its memory size. But when we will just be talking about class as a blueprint, it does not contain any memory size. So no memory size. You can consider it to be as 0, because this is just a template, right? So when a class is just kept as it is just like a template. That is why I can say that the memory size of class is 0. So you can better understand if do you have the APC book with you? If you have the APC book with you, from there you could understand why this is said to be or why the things are kept similarly. In the APC book, just under that particular one of the page, I don't remember that page, there is this particular details that is mentioned. That is, class is, and it's a common thing. It's logically correct as well. That's the only reason why our class is what? Why our class is not having any memory size, right? Yes. Yes, this is one. Ask. Yes, very good. The content decides what memory size that particular class will be having. But only the blueprint of the class don't contain any memory size. Okay. Now as we know that when a class is defined, it is always with various objects. Like, it is just a template, it is just a blueprint. Now a class will be containing many objects in it. And whenever objects are kept in a class, it is said that a class always stores similar objects, right? Similar type of objects are stored in the class. And every object has its own behavior and characteristics, right? Yes. So, hmm, yes, yes. Unless and until it is defined. Hmm, hmm, hmm. Yes, that's correct. You are just you are just writing, but unless and until you are putting any objects inside the class, it won't be carrying any memory size. Okay. Hmm. Okay. No, no, no. Yes. And similar object. Huh. What? Huh. In the programming language Python, you will shock to know this, that we are never defining any class. We just directly write the program, and automatically it asks you. Do you remember when you are writing a word file, when you are saving that particular word file, you are asked the file name? Similarly, the Python works. You won't be writing class name and bigger curly braces whenever you are writing any programs in Python. You will just, as we are writing a code snippet over here, that is the full program for the Python. That is a very beautiful programming language, I would say. You do not need declaration. Directly you will be initializing values. Automatically those values, whatever it's stored, accordingly it will be, the data type will be provided to that particular variable. That's the interesting programming language. Yes. Most of the things are already assisted by the platform itself. Behavior, and as I was discussing, every object has its own behavior and characteristics, behaviors or characteristics. Now, when we are saying that all of the objects in this particular class are similar to one another, we usually focus to its characteristics or behavior. Behavior, very good. We focus to its behavior because every of the object that is present in a single class do has similar behavior or same behavior, while characteristics may differ, right? Characteristics may be different, but behavior will be same every time. Fine. Now if I will be taking real life example, now can you suggest me one example that we can consider as form of the object? Class. Okay. Class, that is, we are talking about schools class. Okay, so do you consider it to be as the object? You consider class to be as the class only, right? Okay, then you consider students as the objects, right? Okay, so you say students are the objects. And how many types are they divided in? Or what are the two things that every student do contain? That is the behavior and characteristics. Yes. Now can you see me some of the behavior? Study, play, so friendship. Yes, these are some of the common behavior. And talking about characteristics, nail. Okay, how did you directly come to nail? Oh, name. I thought, why did you directly come to nail? Okay, that's fine. Name and height, weight, right? Characteristics. Now we can say this, that whenever we are talking about students as objects of the class, the behavior of all the students are same. Every of the students do study, do play, and do friendship. So whenever we are talking about activity of any object, we do consider it as the behavior, right? So whenever we are talking about activity, whatever a particular object will be performing naturally or very often, we will be considering that as behavior. But talking about characteristics, characteristics will be characteristics will be the category, right? And every students come up with various category, right? Name, height, weight. Here we are just writing the category, and every of the students outcomes will be different to one another. So characteristics usually means the category of the students. Name, height, weight. It will be a different one for different student. Student one will be having different name, height, and weight. Student 2 will be having different name, height, or weight, or it may be similar as well, but we cannot consider that it has to be same, right? It may be same. You may come up with a particular student where both of them will be having the same name, height and weight, but it's not always the same. Okay, yes. So this is some of the learnings that we have learned about the objects. And every time, yes, now when we will be when we are bringing the same concept to our programming language, we name the behavior as methods, methods or member methods, functions, right? That's all. And when we are talking about the characteristics, we do consider it as data members, variables, and do we have any other name? Instances can instances are the object, na? Instance of the class, instance of the class. Data members, variables, yes. Hmm. Yes, okay. Or identifiers also can be said. The other name for the variable is identifier, right? So this is what is said. And in our every program that we are doing in a single class, our methods, huh? What? No, 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 no. Token cannot be considered as the characteristics, na? That's a different concept that will be coming when we will be talking about, I would say, about the process that is happening in the program. If we will be bringing the concept of token over here, the whole concept, whatever we are learning, won't match. Are you getting what I'm saying? If we will be thinking about the concept of token, what are those? That is operator, variables, literals, separators. Those all things are there. How can you talk about those when we are talking about objects? We will be talking about behavior and characteristics only, right? Whenever we are talking about objects, yes. So these are the different names. And if we want to represent the behavior, we represent it with a parenthesis. So if we want to write study for in our programming, so it will be with parenthesis. So this parenthesis is the representation of the functions and the methods. Play this, friendship this. Now talking about data members, variables and identifiers. So here when we will be giving it, so every of the object as is having different category. So like I would say ram, name, and if height comes, I will be writing it in numbers. 14, height 5 feet, weight suppose 93 kg. Now we can differentiate because every object will be having different names and all. Shyam, suppose 5.5 feet. Okay, but usually when we will be writing the numbers, we do not represent any physical unit, right? Like feet, kg, like this. Automatically these are understood. 87. Okay, so this is how we will be representing our constants to our variables, or this will be the category or the answer to the category, I would say, right? So the object 1 will be having this all details. Object 2 in our programming language will be having this all details, right? Yes. So this is what we know about methods, functions and the data members at the other side. Are you saying something? No. Okay. So now we have understood what is variables, what are the and we can also say there are other names for the characteristics as well. Can we see it as features as well? Yes. So characteristics are also having other names, that is features, attributes, can we say? Yes. So these are the synonyms of the word characteristics in the world of object. And behavior, as we have already written. Can is there any other word for the behavior? No, right? When we are talking about behavior of the real world, I'm talking about. But we do have various names when we will be talking about behavior in the world of programming language, that is method, member methods, functions, etc. Right? Yes. So by this we have understood each object's encapsulatements do contain the state and behavior, and we have also discovered various examples. We have understood what member variable is, and which is also said to be as its attributes or features. Now we are going to understand variables define state. Yes. Now we are going to understand this particular line, how a variable define its state. Variable define its state. Can you help me out in stating this particular line or proving this line? How can a variable decides state of an object? Yes, very good. With the help of the data type, we do decide the state of an object. So the answer to this is variable that is defined with the state of the object is with the help of its data type. Suppose if I will be naming my variables A, B, Z, C, D, A, M. If I am writing 41, 2.592, 8.4 A. Here if I will be writing Monday, here if I will be writing Monday. So these are the states of the object, okay, and this state of the object is decided with the help of its data type. So this will be with integer, let's say int data type. This will be the most possible data type that it can have is double, because we are having so many numbers after decimal place. So 8.4 is, I can keep it as float, and this will be, as single quote is already mentioned, so it will be char data type or character data type, and the last one is string. Okay, so the state of an object is decided by the variable with the help of its data types. Yes, where is it? Now we will be writing one programming question, and we will be understanding how methods define the behavior, right? Let's see. So whenever we will, what? No, that particular chapter is different. Here when it says objects encapsulate state and behavior, it do mean that object do contain state and behavior. That is a different chapter. The chapter name that we are saying right now, that's a different chapter. That's a different one. Here encapsulates means containing anything. Yes, now we will be observing how methods define the behavior. How methods define behavior. So suppose if we will be defining a class program, let's say, and my intention of building, okay, let me name it differently. Suppose let's say I will be writing here the calculator. So in this particular calculator wala program, if I want to do addition, subtraction, multiplication, division, so what will I be doing? I will be defining 4 methods to make it to perform the task easily, so that whatever numbers will be given by the user, I will be accepting that and I will be doing that 4 tasks. But just for consideration, let me write it in a simple way. So I will be writing public void add. Okay, I'm opening, I'm closing. I just want to represent methods, that's why I'm writing. Now let me keep it as static. Public static double subtract. Then public void multiply. Then I'm having, suppose, public static void divide. Okay, now this is open, this is closed. So these were my methods in a single class. Now let us see how it is defining the behavior of the object. So now what will I be doing? I will be creating the main method. This should be lowercase, p also need to be more small. Yes, public static void main, and inside this I will be creating the object, right? Yes. Yes, I have created the object. Now I want to talk about multiple objects. So for that I will definitely be creating multiple objects. The name of the first object is OB, second is OB1. So I want to create different objects. So these are my 3 objects that I have created over here. Now if I want to do any operation or any activity, that can only be done by calling my functions, right? So let's say yes or no. Hello, is it? Hello, are you there? Are you listening me? But here, dear, as we are only talking about object na, I want this methods whichever I have written as static, I want to keep it as non-static, so that I could show the dependency of the method to the object. So let me make it, rub this out. Consider these are all are non-static in nature. Okay, so that we could better relate to the concept that we are learning. Yes. Now if I want to add something, definitely I will be calling, let me keep every of the object void only, so that those all concepts will become simple. Okay, everything is void. Now if I want to add, so I will be definitely be calling add method. If I want to subtract, I will be calling the method subtract. If I want to multiply, I will be calling the what's the name, it's, is it multiply? Yes, it's multiply. If I want to call divide, I will be calling ob dot divide, devide, parenthesis, and every of them will be semicolon. Now let me write, I'm just writing it for example basis. Okay, that's why I have given a line, and now I will be doing the same thing for my other method, ob1 dot subtract. So this is ob1 dot multiply, and this is ob1 dot divide. Okay, the same thing can be done with the ob2 object as well. So ob2 dot add, ob2 dot subtract, semicolon, ob2 dot multiply. So now there is a very good learning over here that can be learned. So ob2 dot divide, semicolon. Now I can say this by, can you see, all of my objects are dependent upon the same method. If I but my objects are not related to one another. Here the name of the object is ob. Here I am talking about different object, that is ob1. Here I am talking about a different object ob2, but all of the objects are dependent upon the same method. ob1 is also dependent on add, ob is also dependent, ob2 is also dependent. So this is how we can conclude two things: how our behavior remain same for all the objects of the class. This is one of the conclusion that we can draw out. The second conclusion is methods define the behavior. Here every behavior, what's the meaning of behavior? It means it's activity. So by talk means we can basically say, as we have taken the example of student, the behavior of student is to sit, listen, learn, study. So here as well, the behavior of an object, if you will be observing, that is better explained with the help of the method. Here we are talking about the objects of the class calculator, right? So at the first place, the add method is talking about the behavior of ob, that what tasks has to be done, what is the purpose of this particular class that we have created calculator, is well explained by the method, that is the behavior, that is add, subtract, multiply and divide, right? This is how methods define the behavior. Behavior is not the behavior that we speak in our language of English, while behavior is the activity that is done. If I will be talking about a car, can you say me what will be the behavior of a car? Yes, comfortability, it use fuel, rather it be petrol, diesel or electric. Electric is also a fuel, right, that is used, and it basically comes with four wheels, right? So these are some of the findings in every of the car. That is why we consider that as the behavior. So here the behavior of the calculator, it will be adding, it will be subtracting, it will be multiplying and it will be dividing. So this is how the methods of the class do speak about the behavior of it. Okay, so this one also we have concluded with the help of an example. This one. Now class is abstractions for set of objects. Do you understand what this particular abstractions mean? Do you understand what this particular term mean, abstractions? Showing the required feature, hiding the background details. Now we are going to understand how is class helping to hide the background details while showing the essential features for the set of objects that is used in the class. Okay, let's see. So here if you will be observing, how is an object created? Is it with the help of the class name? Can an object be created without the help of the class name? Never. So here we can say that our objects are only defined with the help of the class name. And as every of the objects has its unique entity, right? OB is having its own unique entity. OB1 is having its own unique entity. And OB2 is having its unique entity. So we can say, but in a single program, when we are defining different objects ob, ob1, ob2, They all are having their individual identity. Here you cannot say whatever thing whatever things are happened with OB will be dependent with the OB1, with the OB1. Similarly, what has happened in this particular OB1, you cannot say it is dependent upon OB2. Now, what do I mean when I say not depend? So, the meaning of this is here you are adding, but you if you are adding over here, you may be adding 5 plus 7, that is 12 here, right? And in OB1 dot add, you may be adding 1.4 plus 2.3, that will be giving 3.7, right? See, add is same, but all of them are having their unique identity. All of them have added, but all of their results are different from one another. Here you may be adding 1 plus 2.3, that is 3.3. This is what do we mean, and this can be same for all other examples that is written over here. Can we say this is how our objects, here we have learned two things, that how an object has its own identity, unique identity, and second is how is a class helping this to be maintained. Class is helping because class is the one with the help of which we are creating the objects of the class. And when the objects are created, then the unique identity is maintained, right? That is why we can say that the class is the one that is helping these objects to maintain the abstraction concept, that is the principle of the OOP, right? Yes. So this is how you need to describe or you need to understand whenever you are going through this particular theoretical chapter. This is how the datas are hidden. What is the other concept of data abstraction is data hiding, right? Data abstraction is nothing but data hiding. See, here my datas are hidden. Here this 5 and 7 are the datas that are only known to OB, or OB1 does know this. No, right? See, datas are hidden, and when datas are hidden, that is how you can show that it is unique entity, because all of the datas are kept hidden from one object to another. And as I said, objects are created with the help of the class. Yes. So you can draw out this particular conclusion. Yes. Now class as an object factory. How class is a place which is why class is said to be as an object factory, right? That's easy. That can be addressed very easily, because inside a class, the possibility, we can start in this particular way. The possibility of defining, say, are you asking something? Ask. No? Okay. So I'm saying the only possible way to define a class is with the help of the with the sorry, excuse me, yes, I'm saying the definite way or the true way for defining an object of a class is with the help of the class name. Yes or no? And with the help of the class, we can define as many objects as we want in our program, right? That is why a class is said to be as the set of objects, but the inverse cannot happen. What do I mean by inverse? Let me define. Class is a set of objects or object factory this is all. Why? Because there can be hundreds of objects that can be defined. One is inside a class, and the second is with the help of the class name. With the help of the class name. Right? That is why we can say class is a object factory, because class has the capability to define as many objects as we want, right? That is why we can conclude class as the object factory. Yes, now we have understood this. Okay, now as per the syllabus, we do have types of data types. So basically, what is data type? Do you remember the definition of it? The definition for the data type? Yes. No. Yes, let me explain. So data types are nothing but these are something that decides the types of values that can be stored in a variable. This is the number one. Types of values that can be stored in a variable is decided by our data type. And the second is memory size that a variable do consume. Okay, a very common one, but we often do not discuss about the definition, but we apply it in every parts of our program, right? Whenever we write a program, yes. Now we need to understand how many types these data types are. How many types are they? No, majorly they are divided into two types. Data types are of two types: primitive and the composite. Primitive and non-composite, or primitive and non-primitive, right? So we can write that our data types are broadly divided into two types, that is primitive type. And what's the definition for primitive type? User defined data types or inbuilt? Primitive data types are inbuilt data types. Inbuilt data type can be said. Fundamental data types can be said. Fundamental data types. Or independent data types can also be said. And talking about non-primitive data types are dependent, right? These are dependent on primitive types, isn't? Yes. The second is, we can consider it to be as composite data type. We can consider it as user defined data type. These are some of the names that can be given to our non-primitive data types. Now talking about primitive, majorly they are of two types. One is numeric, another one is non-numeric. And in numeric as well, we do have two types. One is non-fractional, another one is fractional. Talking about non-fractional, we can start with byte. So byte, whose memory size is 1 byte. Then comes short 2 bytes. Then comes int 4 bytes. Then comes long with 8 bytes. Talking about fractional, float that comes with 4 bytes, and then double that comes with 8 bytes, right? Yes. Talking about non-numeric, we do have two. One is char, that that is of 2 bytes. Another one is boolean, that is majorly said to be as 1 bit size. Yes, and talking about composite, we do have many. We do not have uh, this kind of infrastructural differentiate between this particular, like we have studied here, numeric and non-numeric. We do not have certain infrastructure for this particular composite. So we can say class is a composite data type, string is a composite data type, array that we are going to learn is a composite data type, right? This is what we need to understand very properly. And as we know that our composite data type do not have any definite memory size, like every time they are dynamic in nature. That's why I have not represented the memory size of them. Yes, so now we have understood about our primitive type and our composite data type, right? Yes. So that's all for today's session. Thank you for watching this, and bye bye.